Welcome to this video tutorial on the building blocks of geometry, specifically naming line segments, naming angles, and incorporating some probability. The picture on the left is what we will base this problem off of. It'll have three components. First, we're going to look at line segments. Of course, you're welcome to hit pause on this video and try to work this problem out before we discuss it together. Before beginning, on the left, it's a solid line segment, and on the right, those points are collinear as well. So let's start off with the left-hand side. Let's name that over here with as many line segments as exist. First of all, we've got A to B, and we also have AC. I like to name each line segment starting with point A as an endpoint first. And now we've taken care of A, so we'll move over to B. And we have line segment BC. That takes care of the left-hand side. Let's move over here to the right-hand side. We've got line segments with A, D, E, and F. So we'll start with AD. And then we'll go AE. And finally AF. That takes care of all line segments on the right-hand side that have point A as an endpoint. Move over to D. We then have DE and DF. And then move to the last portion, we have EF. Hopefully you remember from class that if you've named these things correctly and have named all of the items that we're looking for, they form these triangular shapes. Now we've got the little offshoots that we have to take care of. We have BD, we have BE, and we have BF. Color coding and organization can help tremendously. I think we have them all listed. Look back at the picture and make sure. And then we'll count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 line segments, it looks like. Which leads us to the question about probability. What is the probability that a randomly chosen line segment in the picture contains point E? Well, probability is a fraction, and there are 12 total line segments. So we will put the 12 in the denominator. Now be careful on this. Containing point E. Which line segments contain point E? Well, of course we have the ones where E is an endpoint. So for example, AE, DE, EF, and BE. Those are the line segments where E is one of the endpoints. But don't forget, and I'm going to star this right here, don't forget, the line segment contains E if E is on it, but not an endpoint as well. So for example, DF will contain point E. AF will contain point E. And I think that would be everything then that would contain point E, either as an endpoint or as a point on the segment in between its endpoints. So now count it up. How many segments contain point E? 1, 2, 3, 4, 5, 6. 6 of those line segments contain point E. There are 12 total. Simplify it and write it as a simplified fraction. 6 over 12 simplifies to 1 over 2. Now hopefully we're all good on simplifying that fraction, but for those of you with the TI-84 or TI-83, it's very simple. Type 6 divided by 12, hit enter, hit the math, convert to fraction button, hit enter, and it will display the simplified fraction. Again, this problem wasn't bad. Hopefully we can reduce 6 over 12 to 1/2, but please be aware of where you look to simplify fractions. The other problem that we're going to look at with this same picture is how many angles are in the figure, and we're going to name them each once. The big idea is to name them by vertex. Stay organized. So first we'll start with vertex A. At vertex A, there's one angle chilling there, right here. We're going to name it angle CAF. A needs to be the middle letter, and I would highly recommend to name angles with 3 letters. Otherwise, there are some times where that isn't possible and it throws you off. We're now going to scroll over to vertex B. We're going in alphabetical order. I'm going to start with the small angles, and notice I'm highlighting them here in red. There appear to be 4 of those smaller angles. So I'm going to start with angle CBF, and then we have angle FBE, followed by angle EBD, and finally angle DBA. Next, we're going to skip a ray, which will give us these 3 angles that we have just shown in blue. So be careful, it's going to be angle CBE, angle FBD, and angle EBA. Oops, I want that to be an E first, angle EBA. Then we're going to skip 2 of those rays at a time, and there's going to be 2 resulting angles. The first one is CBD, and the other one is angle FBA. Now that picture hopefully captures all of them, except we haven't gotten the whole thing, which would be angle ABC. But hopefully you see what's wrong with angle ABC. It's a straight line, and we said we were not going to consider straight lines as angles. So we'll remove it from our list. Vertex C is next. Ah, there's none. That was easy. Okay, so let's go to vertex D. Vertex D, oh look at, we've got 2 of these smaller angles here to work with. So in order to help us see it, I'm going to back up a little bit and erase some of these things that we have here in green. So give me just a second, and as I erase this, perhaps you can check to see if you can name all the angles who have a vertex at D. So let's start with these 2 small ones that I'm putting in red. We've got angle ADB, and we've got angle BDE. Now you might have named them differently. Maybe you said BDA. Maybe you said EDB. That's fine, but name each angle once. Here though, we are not going to use the whole name, the whole angle of ADE. Hopefully again you see why we wouldn't use ADE. It's a straight line. And we said straight lines are not going to count, for the moment, as angles. Then we've got vertex E. So when I look at vertex E, again I'm going to start with red for the small angles here. We've got angle A. I could name it AEB, or I could name it DEB. I'm going to go with AEB. Either way would be fine. And then we've got angle BEF. Again, we are not going to include, let me change the color on that. We are not going to include DEF because that is a straight line. Now here's where the organization is important. We still have vertex F. It keeps us mindful of what we've done and what we still need to do. At vertex F, there's one angle, and that would be this angle that we could name as AFB, or DFB, or EFB, or BFE. Just pick one of those names. I'm going to go with AFB, and that should be all of the angles. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Make sure you answer the question in its entirety, it appears there are 15 angles in that figure. Stay organized, and notice that triangular shape still works. The reason why it didn't finish off in its entirety is because the straight line was excluded. But keep organized, stay organized, and the problem should work itself out very well. Another thing that I like to do here at the very end, just to make sure I'm right, there's 1 at A, 1, 2, 3, 4, 5, 6, 7, 8, 9 at B, 2 at D, 2 at E, 1 at F. 1 and 9 is 10, 12, 14, 15. It doesn't hurt to double check. Thanks for watching Building Blocks of Geometry.